Today we are going to discuss on the topic of mechanical translational system, which comes in control systems, and I am Mr. S. Joshua Daniel, Assistant Professor, EEE Department, Hindustan College of Engineering and Technology. We have the various list of symbols used in mechanical translation system: X for displacement, V for velocity, A for acceleration, and we have the different notations for applied force and for opposing force. We have three different elements in mechanical translational system. One is M for mass, K stiffness of spring, D which is called as dashpot. Let's see the different equations which deal with mass, spring and dashpot. Here we have the mass which is fixed to a reference, and if it is applied with a force F, it has a displacement x. So using Newton's law, applied force is equal to opposing force, we have these equations. So by using Newton's second law, F is equal to Fm, that is equal to m d square x by dt square. Next, we'll see the dashpot when fixed to one end to the reference. Force is applied to the dashpot. When we write the equation, we have using Newton's second law, F is equal to Fb, that is equal to b dx by dt. Next, we'll see if the dashpot is connected or it has displacement at both ends, it will have displacement at both ends. So we replace that displacement x as x1 minus x2. Next, we'll see the spring with one end fixed to a reference. So this is fixed to the reference and it has a displacement x. So let's see what is the formula. Using Newton's second law, F is equal to Fk, that is equal to Kx. Next, we'll see what happens if the spring is connected or it is having displacement at both ends, that is x1 and x2. So we replace the same formula with F is equal to F suffix k, that is equal to capital K, x1 minus x2. Now let's see what happens to the displacement, the velocity and the acceleration when we take Laplace transform. So x of t, when you take Laplace transform, it becomes capital X of s, and dx by dt, when Laplace transform is taken, it is as s x of s, and d square x by dt squared, when Laplace transform is taken, it is s squared x of s. Now let's see a problem. So in this problem, we have two masses m1 and m2. We have dashpot capital B, B1 and B2, and we have two springs, that is K1 and K. Next, what we have to do is we have to write the free body diagram of mass m1 and all the elements which are connected to mass m1 will give the opposing forces. Similarly, we have to write the free body diagram of mass m2, and the opposing force is given by all of the elements which are connected to m2. So here in this problem, transfer function is asked. So we are writing the free body diagram of mass m1. So these are the opposing forces, that is on mass m, Fm1, and the opposing force due to dashpot B1, the opposing force due to dashpot B, the opposing force due to spring K1 and spring K. So we need to write the different equations for all these opposing forces, and then by applying Newton's second law, we are going to equate the force applied is equal to force opposing. So we get this equation. Next, we are going to take the Laplace transform for this equation, right? When you take Laplace transform, we have m1 s squared x1 of s plus b1 s x1 of s plus b s x1 of s minus x of x, plus for spring k1 x1 of s plus k x1 of s minus xs that is equal to 0. Since why we have noted here 0 is there is no any applied force on mass 1. Next we rearrange these equations and we get an output as x1 of s, that is equal to x of s bs plus k the whole divided by m1 s squared plus b1 plus b of s plus k1 plus k. We keep this as 1 since what is asked is the transfer function, right? So we are rearranging these equations to find the transfer function. Next we are writing the free body diagram of mass m2. Similarly, the applied force as well as the different opposing forces on that particular mass 2. We write the different equations which are related to the opposing force. Then using Newton's second law, we write the applied force is equal to opposing forces and we get an equation like this. Next we take Laplace transform for that equation and we write the equation in this form. Since in our question transfer function is asked, which is nothing but excess of by divided by fs, we rearrange these equations such that we get x of s by f of s, which is nothing but the transfer function. We rearrange these equations and in place of x1 of s we substitute, we have found out in the previous slide, so we substitute that and we find out the transfer function. Thank you.